Our guess is that we will, and it is an educated guess, is that we will have a machine of substance, of consequence, within about a decade.
A decade?
A decade.
Okay. Is Moore's law working here, or is there something like Moore's law working here?
There is wonderfully a double Moore's law running to our advantage. Okay. The ability to actually build better and better bits, quantum bits, has got a Moore's law with about an 18-month time. Okay. Mm-hmm. At the same time, the people developing algorithms that are going to run on this thing have become less and less demanding. So there's a negative Moore's law running on the demand from the algorithm developers. That's why I say it's a double Moore's law. Mm-hmm. So I'm reasonably confident that quite soon we'll be able to find ways in which we exploit these noisy intermediate scale machines for doing something in terms of the simulation of things and optimization. Mm-hmm. So some of that is already underway, I reckon. And so we're beginning to see something of economic importance quite quickly from those noisy machines. Building a large-scale machine, which is what the press always concentrate on, is harder, and that will be a decade away, at least. Okay. So people often talk about the fact that a quantum machine will undermine our entire internet security, because at the moment with TLS and RSA and the rest of it, we're wholly dependent on the inability of a classical machine to conquer what's technically a hard problem. Mm-hmm. And it's basically factoring. Mm-hmm. Okay, checking you got the right answer is dead easy. It's called multiplication, and it's only polynomially dependent. But the factoring is exponentially dependent on the size of the problem. But a quantum machine changes all that, because there's an algorithm, Shor's algorithm, which shows that you can, with a quantum machine, turn what was an exponentially demanding problem into a polynomially problem. So, for example, within about 10 years, we have to assume that everything that we use to secure the internet has to be replaced by something which is immune to a quantum attack.
Okay.
And that I've been working quite a lot on this issue, along with many others. If your best guess for a large-scale quantum machine is a decade away, how long does it take to completely re-engineer all of the things that secure your internet? What your cryptographic primitives? And you work up the timescale for that, and it's about a decade. Mm-hmm. So when do you start working on rolling out quantum safe encryption or post-quantum cryptography? Well, you better do it about a year or two ago. Okay. Right. So part of our problem space is to work out how we can make quantum resilient or quantum resistant architecture in the internet. And we know in principle how to do it. Okay, but it takes a while. You have to stress test it, road test it. You red team, blue team it to make sure that you haven't left any vulnerabilities in, and so on. And it's a long process that's underway. The second part of it is to start working with all of the sectors of the economy that depend upon this to make sure that they're alert to the need to be quantum ready. So part of what we've been able to do is build this thing called a quantum readiness program, where we are talking to the banks and to others and to the data centers and providers to make sure that they have an alertness to what is necessary to engineer in this. So that is even though you don't yet have the machines to do that cracking of conventional cryptography, that rollout procedure has to take place. So working with the banks, working with HSBC, for example, or Barclays, they are now all fielding quantum teams to work on what has to be in place to make sure that we have a resilient internet.